All right, guys, can you hear me again?
Yeah, we can hear you.
Yeah, I can hear you.
So I just spoke with Anna. She says that Monday before the final exam, Monday the 20th of December, that morning should be free for you guys. And so this will be a good time to have office hours. So I'm going to put office hours on Monday, December 20th in the morning. And so bring all your questions to that office hour, and I'll try my best to answer them. Having these math discussions over email, it doesn't work. We need to do it face to face. So I put the office hours there, so then there is a chunk of time where we can have a math discussion. I'll ask Sherry, the TA, if she can have some office hours too when they get closer to the final. But in the format of the final is going to be similar to the midterm. We'll talk about some of the homeworks that you guys have had. Right, so you can see already now that we haven't had any homework on foreign exchange, right? So this foreign exchange material that we're doing today, this is not going to be relevant for your final. That being said, foreign exchange is a quite important class of derivatives that we're talking about. So knowing something about foreign exchange is of course a useful thing. And you will see foreign exchange, there's a formula that is almost as famous as Black-Scholes, and it also looks a lot like Black-Scholes formula. When you go and when you get into 622, that there's going to be a formula that's known as let me bring it up here. Right, so this here is the book that you're going to be using for 622 in the spring. So just to skip ahead a little bit about what to expect in there. There's a section up here, section 9, which is about foreign and domestic. And there's this really famous formula called the Gauman-Kohlhagen formula. It's on page 390. And that formula, you can see the notation here is Q again, just like what we're talking about. And if you remember a little bit of some of the Black-Scholes calculations that we have had at various points, so you see there's these D pluses and D minuses, you can see there's something with R and RF. So there is really a quite in the same spirit of what we're doing here. Of course, it's more complicated because it's in continuous time, but there's this very famous Gauman-Kohlhagen formula that you're going to see in 622. So there's a lot more foreign exchange coming your way. You should see what we're talking about here, just as setting the stage and trying to talk about some of these things that are quite central to any material on foreign exchange. Okay, are there any questions about what we did before the break, before I forge ahead with foreign exchange? So just to summarize, right? What we have given, what we're given, right, we're given this process Qn. This is up to some n, right? This is the foreign exchange. The foreign exchange rate, right? So you convert by multiplying, right? So you go from pounds to dollars by multiplying. So you're given that, then you're also given the two bank accounts. You're given MN, which is 1 plus R to the power n. Right, so that's the domestic bank, and then you're given the foreign bank. Right, and these are not random, right? R and RF are constants here. And so everything centers around this object that we could call Sn. Don't be misled. This is not a stock. This is a risk of security, right? And what you do is you take the foreign bank and then you multiply it onto the right. So this is going to give you something in this is going to give you something in pounds, right? And then you multiply on foreign exchange rate, right? And it converts this foreign amount into domestic amount. Okay, so this here is the price process. This is the price process in dollars of the foreign bank. So this is a price process of something traded, so it's going to have a martingale property, right? So Sn divided by Mn is a P tilde martingale. And this is where everything comes from. And we're going to be using this property over and over and over. We used it a couple of times before the little break we had, and to get right to answer the two problems number 2 and 6. So the next thing that I want to talk about is forward. So again, we're going to use the word forward. So we're going to use forward foreign exchange rates. So not current ones, right? The QN is what you multiply on to convert now. So forward foreign exchange rates. Okay, so the way that goes is we have time points N and M. So here at time M, you're going to convert £1 into QM dollars. So you're going to exchange. You're going to exchange £1 at time M for this fair value. It's called FORNM. Right, so if you're sitting at time M, you can convert £1 into QM. Okay, so now we're going to do a different deal. What happens if you sit earlier? But this thing here is going to be Fn is smaller than M. This is going to be Fn measurable. So what's the payoff? The payoff is going to be, so time M payoff is going to be QM minus, and then this constant. This is going to be payoff in dollars. So this value here, the usual one is the price. It's the thing that makes the value of this payoff at earlier times equal to 0. So this 4NM is Fn measurable. So we get this payoff here, that one, at time M. We're going to figure out what is the fair price of it. Right? So we get time N, which is less than M, value. Well, we discount back to time 0. Take expectation. And then we use that this value here is to be chosen such that this is a big 0. This here is how this forward exchange rate is set. But you can see, because we have deterministic interest rates, it's going to become this ratio here is not random, right? So you can travel outside and you can divide through. This is going to be the same thing as saying that the expectation without it this is because RF and R are constants. And then you can use that this one here is measurable. So you'll get that the forward exchange rate is exactly the conditional expectation of that future exchange rate. This year, we should condition. Remember, when we have a random variable and we condition, we're going to get a martingale. This one here is a P tilde martingale. And we can work out what this is, very similar to what we had done before. We can work out what this expectation here is. So we can use this martingale property here. We can use that MNF times QN divided by Mn. Let's write out what it is. Use 1 plus Rf to the power n Qn divided by 1 plus R to the nth. We can use that this thing here is a P tilde martingale to work out what this one here is. So let's give it a go. Let's see what it is. E tilde. We know it's going to be a martingale, but maybe we can reduce it a little bit. So if I take QM given Fn, I want to write it in terms of what I have here, because this is what I know is a martingale. So I want to write this as QM times 1 plus Rf to the power m divided by 1 plus R to the power m given Fn. Now, of course, the equality sign is not true, so I need to correct for it. So I only have 1 plus R here to the power m divided by 1 plus Rf to the power m. And that's a lot better because now I know that this here is a martingale by this property up there. So the conditional expectation is easy to compute. I get 1 plus R to the power m, 1 plus Rf to the power m. And then because it's a martingale, I just replace m by n. I get Qn, and then a ratio 1 plus Rf divided by 1 plus Rn. And so I have my forward exchange rate. I simply get that out. I get that the foreign exchange rate that was this conditional expectation here. It's equal to this mess here. So it's equal to Qn times some factor. We have 1 plus R to the m minus n divided by 1 plus Rf to the power. What will it be? It'll be the same power because I have to put it all outside. So I know that this here is a martingale as well. So that's the expression for the forward exchange rate. So what I had in mind was to solve a couple of problems using this. Before I switch over to solving problems, are there any questions on what we've done here? This is very similar to what we were doing before. Before, when we had forwards, we needed the forward measure. We don't need the forward measure here because we have deterministic interest rates, right? Remember that result we had about futures and forwards. They were all the same when the interest rates were the same. And we're seeing some of that here too. We don't need to introduce the forward measure because the interest rates, they were not random. Right, so we already get the martingale property of the forward exchange rate under the P tilde measure. We don't have to change it into forward measures. Okay, so the last thing I want to do is to solve a couple of problems based on what we're seeing here. And I had in mind, let me just double check which one we should do first. I think the first one we should do is either 47 or 48. Let's give it a go with 48. Bring it up. So here we have problem number 48. So what are we giving? We're giving an exchange rate model, a couple of periods. Now we're modeling the forward exchange rates directly. We model in them as Fn plus 1 being Fn and then times these coin flips, psi n plus 1. Psi 1 and psi 2 do your IID. You could take values, U being 2, D being a half. The initial forward rate was given to be 4, and the domestic currency, the domestic bank account was 25%. All right, so now it becomes more complicated. So that's the setup. We have these forward exchange rates. Those are our basic building blocks. And then we consider a call option. So the payoff at time n is, so we're going to be looking at a call option on top of this. Call option, so this payoff at n, capital N is equal to 2. It's just the forward exchange rate minus 4 positive part. So this is something that happens out of time 2, and we need to price it. Price of option, of call option at time 0. But we have an option that is written on this forward exchange rate, and we're being asked to price a call option on that exchange rate. Okay, so what to do? Well, I mean, we know how to price these things, so we roll them back and compute the conditional expectations. So this is what we're going to be doing here too. So we know to get our hands on, so to compute this conditional expectation, we need P tilde and Q tilde. What we just did, what we just proved, we just worked with these foreign exchange rates, right? So this 4 here, this is that F in the problem. And what we showed here was that we have a martingale property. Right? This here is a martingale. So this Fn process that's given in the problem, it has to be a martingale. So let's maybe start by working that out. We know that this Fn, this is a P tilde martingale. Okay, so the conditional expectation of Fn plus 1 given information up to time n, we know that this is Fn. So let's try to work that out. What we have up here is Fn plus 1 is Fn times that coin flip. So this has to be Fn. The condition. right? And that's measurable, so you can go outside, and that will be independent. We've seen that many times. So the f's will cancel out. We're going to get that the expectation of psi n plus 1 is ought to be 1. Okay. So what is that going to tell me about p tilde? This is the same thing as saying that p tilde, the size could take two values. This is u plus 1 minus p tilde times d. That this will be 1. So now we're going to use that u is 2 and d is a half. So we have p tilde times u minus d equals 1 minus d. So this is the same as saying that p tilde times u minus d, this is what? 1.5. 3 divided by 2. That this is equal to a half. This is the same thing then as saying that p tilde is equal to a third. Okay, so the implication in this question here is that if you tell me what these things here are, and I know that this here must be a martingale, well, there's not a lot of choices for what p tilde and q tilde should be. It has to be a third. So maybe we can, so given that, so now I know what p tilde and q tilde are, and then I can proceed by pricing the call option, because it's going to be given as the discounted future payoff, right? So at time m, sorry, at time n we have a payoff. At time n, what do we have? We have a payoff of fn minus 4. So we have a payoff. This is going to be fn minus 4, positive part. So we have, I think we call those for, we had these payout functions fn of x. So this will be the payoff at time n. I think in the problem n is equal to 2. So we could define the payoff function simply just being x minus 4 and positive part. And so then what we do is we go 1 back. We go 1 back, and we will roll it back. I mean, ultimately we want to roll it all the way back to time 0. We roll it back 1 by 1. So we will be looking for what is it we have? We have a tree here. We have a tree here, right? And so we're given here we're sitting at time 0, time 1, time 2. What are the forward exchange rates? Well, it's going to be this these fn's that are given according to the size, and the size can go up and down. Right? So you can go from 4 to 8 to 16. And you can go from 4, then you can go up and up. You can go up, and then you can go down, and then you can go down, down, and down. So the payoff here would be at the end, right? It'll be fn. Then you have to have 16, 4, and 1 instead of x here. So we take 16. We're going to be looking at 16 minus 4, a positive part, right? So this will give you a 12. The next one would be 4 minus 4. That's this guy. That will be a 0. And then here you will have 1 minus 4, positive part. That will be a 0. So you have this payout here at the end. And what you want to do is you want to move this forward. You want to move it from out here, and you want to move it into here. And so that's that function we've been calling for f1 of x. And so what is f1 of x? well, we have to take these two future values like 12 and 0, and then we discount them. So we're going to get that if1 in the upstate. So if I go up to 8, what would that be? It would be 1 divided by 1 plus r, and then you need your p tilde times the up value plus 1 minus p tilde times the down value. We settled on p tilde being a third. So we need a third here times 12, and then 1 plus r. We need to look at the problem. What is 1 plus r here? 1 plus r is 1 divided by 1.25. So what does it come out to? This will be 12 divided by 3 is a 4. 4 divided by 1.25. What is that? Something like, what, 3.2? Yeah. And of course, if we are in the downstate is not nearly as exciting because you have a 0 and a 0, so you're going to get a 0 here. So 12 and 0 becomes what? 3.2. 0 and 0 becomes 0. And then you move these two out to 2 times 0 as well. Do that, you can get that. So if 1 of 2, this is a 0, and then you finally get if 0 of 4, it'll be 1 over 1.25, 1 over 3 times 3.2. And if I've done these numbers correctly, I get something like 0.85333. So that was the price. That was the price of the. That's the price of the option. You can of course also set this up instead of just using the risk neutral calculation. You can set this up with a replicating portfolio, and you can work it out. And of course, you're going to end up with exactly the same answer. The solution has all that in it. Any questions on this? So the tricky part here perhaps was you're not really given what the risk neutral probabilities are. You're given what this process here is, and then you know from the theory that we just went through in class that this object here has to be a martingale under that measure. Okay, so that's going to imply what p tilde necessarily must be. Any questions on this? If not, then I want to do a couple more. I had 2 more prepared, so let's try to have a look at 40, 48. No, that was one we just did. 47. 3. Trying to find it. Let's try to do problem number 3. Okay, so let's try to do number 3. Try to do problem number 3. So what are we given? Now we're given the exchange rate, U's and D's. And then you're giving a forward sterling call option. A forward sterling call option gives the writer to buy 1 unit of foreign currency at time 2 for the strike price given by the forward exchange rate F1. Okay, so this is complicated now. This is a mixture of a forward exchange rate and a forward sterling call. Right, so what we're used to, usually, Let me write this here on a piece of paper so you guys can see it. So usually we're looking at calls like there's some underlying quantity. If I call it Sn, right, and then you have a strike. This is usually you have this thing, and then K here is a constant. But now it's different. Now we're looking at a, so here it's different. It's a forward starting call. It's a forward starting call. So let's look at the timeline we have. We are having a model that has 2 time points. So 0, 1, and 2. Right, so this is where we're at. Then there are 2 future time points. So we're gonna have our foreign. We have our foreign exchange rates. These were our F0, F1, and F2. And of course, F2 is always going to be Q2. Good on that. Now, the difference is that, what is the difference between a standard call and a forward starting call? Well, the payoff here is not going to have this form that we're used to. The payoff here is going to be written on, it's going to be written on Q2, but the strike, instead of having a constant strike, the forward starting call is going to have the forward price inside here. So let's just see how it's formulated in the problem. So when you have forward starting calls, then the strike is not constant. Right? So a forward starting call gives the owner the right to buy 1 unit of foreign currency at time n. Okay, so that is the thing that's controlled by Q, and the strike is given by this forward rate F1. So you're asked to compute the price at time 0. Let's try to do that. Now we have deciphered what it means. Forward starting call. We could also, of course, have had, we could of course also have considered, we could have considered the put structure. Alternatively, we could have considered the put, right? So that would have been F1, the forward starting put, this would have been F1 minus Q2 plus the pop. So there are lots of things that we have to figure out here. We have like the starting point should be, we need to figure out what is a good expression for F1, and then subsequently we have to price this thing. Okay, so let's try to have a go at it. There's always going to be a martingale property that is essential to get things started, and the thing that we know as a martingale is we know that if I take the foreign bank account and I multiply onto the exchange, I'm going to get a price process in dollars, and so I know when I discount by the bank in dollars, this is a martingale. And so what does that give me? We've done this calculation here already a few times, but let me do it one more time. So if I take MNF plus 1 divided by MN plus 1 times QN plus 1, this here is going to give me, this thing here is going to give me the same quantity, but at time n. And as before, this ratio here is not random, so we can pull them outside. And we can write this here as MNF times 1 plus RF divided by, I already had this one here a few times, so this is the same thing. I'll pull this quantity outside, and I'll get Qn plus 1 given Fn, and then divided by Mn 1 plus R. And now we can see that structure we've had before, right? MNF is here and here, and this Mn is down here, and you cancel out. I will get that the conditional expectation of Qn plus 1 given Fn, that quantity has to be Qn, and then multiply onto the ratio, of the two interest rates, Rf and R. So this thing here has to hold. What is that going to imply for my probabilities? Well, we were given, what was the notation we were given in the problem? We were given that U and D had specific values. So I can write this here as the expectation, and then Qn times psi n plus 1 given Fn. And this is measurable, and that one's independent. We're going to get Qn times the expectation, psi n plus 1. No conditioning because you have independence. So you see the requirement now, 1 plus R divided by 1 plus RF. It's on the right-hand side, the Q's, you can cancel them out. This expectation, this will be P tilde times U plus 1 minus P tilde times D. But we are given what U and D are. We're given what U and D are. This is P tilde. U was 3/2. D was a half. We were also given here we were also given what R and what RF are. So this here is Qn. R was given to be 25%. RF, the foreign, was given to be 50. So you see, now we're exactly in this situation again. We have one equation, the Q's cancel, right? So we have 1.25 divided by 1.5, and on the right-hand side, on the left-hand side, sorry, we have this expression here. So we solve for P tilde in the equation that says 1.25 divided by 1.5. This should be P tilde 3/2 minus a half plus a half. This just uses this, right? There's a martingale requirement here. That martingale requirement is going to imply that P tilde has to be something specific, a property again that we have had before, and one can go ahead and solve this equation here. And what did I get in the end? I get the same value as in the last one. P tilde is a third. Okay, so at least we got P tilde nailed down. This is a third. Now to solve the problem, we have to value this payoff here, Q2 minus F1, right? And normally we do not have a random here. When we just have a standard call, then what's in here is just that coefficient up there. But when you have a forward starting call, the game is different. When you have a forward starting call, then the strike is not a constant. So first we have to figure out what this F1 here is. So let's try to figure him out. How do we get F1? So we need F1. And again, if you're in doubt about what F1 is, you just return back to the formulation of the problem. What does the problem say that F1 is? The strike is given by F1 in the forward contract, initiated at time 1 for delivery at time 2. We know that forward when there's delivery, right, then this is when the forward ends, and of course F2 is going to be exactly Q2. So we need the first line of business is to figure out, after we figured out what P tilde is, then we want to figure out what F1 is. And how do we figure out what F1 is? Well, we use the theory that we just been through, like F1 has a martingale property. And one has a martingale property, right? So you know what is F1, right? So F1 is the fair value in F1 is the fair value in the, you get the payoff Q2 minus F1, then you discount it. You discount it back to time 1. So this is 1 divided by R. Compute the conditional expectation and get a 0, right? That's how you get, this is the requirement on the forward. And as we saw before, right, the forward price has a martingale property. 1 plus R can go outside, and F1 is the F1 measurable. So you're going to get that F1 is the conditional expectation of Q2 given F1. But that we can calculate. That we can absolutely calculate. We even indeed already did it. We already did it, right? The calculation here from before, conditional expectation of Qn plus 1 given Fn, that's exactly what we have here. Just copy paste the result, and this will be Q1 times 1 plus R divided by 1 plus RF. So that was how we got our hands on F1. Now, given that we have our hands on F1, we can now start pricing this thing. Right, so the option payoff at time 2, remember what it was? It was Q2 minus F1. Now there's a positive part, right? That's the difference down here. Is when you calculate this expression, right, there's no positive part here. For the option, there's a positive part, so we need to put a plus. So Q2 minus F1 positive part. That's the payoff. And now we have an expression for what the what F1 is. So this was Q2. We can write it out in terms of max to make it more clear, perhaps. So we have a max with 0, and then Q2 minus, and then plug in what F1 was. Just calculate what F1 was. So this is Q1 times 1 plus R, 1 plus RF. And now we're good to go. Now we're good to go because we can just grow our tree the way that we usually do. We'll have Q can take 2 values, time 1. And at time 2. Out here, we're going to get this payoff. This is what we've been calling, what did we call it? We called it for F2. So if I grow the tree, for Q, so Q0 was given to be 4. And then you can go up and you can go down. If you go up, it's with, was it 3/2? 3/2, so go up to 4 times 3/2. You go up to 4 times 3/2 times 3/2. And likewise, you can go up and then you can go down. So this is 4 times 3/2 and then D was a half, and you can go down, so it will be 4 times a half, and then you can go up, so it'll be 4 times 3 over 2 times a half, and then you can go down and down, 4 times a half times a half. So what that gives you now is, if you go on the top path, then what will happen is you'll get one payoff, and you'll have Q2, that'll be this value there, minus Q1, that'll be that value there, times that ratio. Okay, so what is going to be F2 in that case? You can see here, there's path dependence, right? It's not just Q2 that matters, it's also what Q1 is. This is because of this forward starting feature. So what you want to get here for F2, if you go plug these numbers in, plug in what R and what RF is, then you'll get here, you'll get 4, and then you'll get, I think, heads and tails, it'll be 0, and then you'll get tails and heads, this will be 1.333, and then you'll get a 0. Right, and then you have your, you have your 4 values, right, and then you just roll them back like we usually do. 4 times right, so these will be the F2s, right? So you also need to get the F1s. F1s will be what, 4 times P tilde was a third, and then 1 over 1 plus R. That'll be this value that'll go in here. You don't have to worry about the 0. Right? You just have 4, and then 1 over 1 plus R. The one down here will be, it'll be 1 over 1 plus R times a third times 1.333, and so on. And if you work out what these two numbers are, I get 16 divided by 15 here, and I get, for the lower one, I'll get 16 divided by 45. And of course, then in the one in the middle, it's just going to be 1 over 1 plus R, and then a third times the up one, 16 over 15 plus 2/3 of the down one, 16 over 45. And if you work out what all that stuff is, this is what you're going to get here. You're going to end up with, what do you get, 64 over 135, which is then going to be the price of the forward starting call. And again, you can set up the replicating portfolio, and you can figure out how you should trade in order to create the replicating portfolio. I think this is enough for me today. Do you guys have any questions? We did a little bit about foreign exchange here. You're going to see that more in later courses as well. Any questions? Any comments? If not, I will still have office hours on Thursday, and you guys are welcome to come and ask questions about the material. Also, if you want to prepare yourself for the final, that's all perfectly fine. Okay, if there are no more questions, then I will see you guys on Thursday. It's Friday morning. I have office hours on Friday morning, or if not before, then I'll see you. I'll see you in the week for the final.
Thank you.
Take care.